Hi everyone, welcome to this video dedicated to static libraries. So the idea today is to start from our project on the square root, now structured in some directories, and now to change at least the computation of the square root part into a static library. So we'll do this together like that. So we are in our project directory, so we are at the root. In src we have our source files for the square root computation, and that's the part that we want to change into a static library. And then to compile the example, so this guy, mysquareroot.c, so not anymore by linking with objects, but linking with a static library. So what we will do is basically only changing the way things are compiled. So we will not change the application itself, okay? Application remain unchanged. Here we go. So compilation for now is in a simple shell script, so which is like that. And okay, so this guy will not change, but these two guys do not change, because in any case we are doing compilation, separate compilation. But now we will create here in between a static library. So static library are created with the command ar, so it's like archive, and so with option R. Okay, and here I want to create the static library into the obj-dir. So, and by convention, all libraries have so starts with lib, so lib. Okay, so that's a convention, and there is another convention when we use them, but okay. And let's call our library square root, so sqrt. And as it is a static library, so the extension convention is .a. Okay. Now what we have to do here is to tell AR all the .o that we want to pack into this static library. So a static library is nothing else than a packaging of several object files. Okay, so for example, and it's our compute.o that we want to pack here inside. Good. And then we have our static library. So let's start by just doing this. Okay, so now we have an additional line here that create normally this guy. So okay, and so this guy is really there, and we have our lib square root.a. First thing that we can do is try to look at the different symbols that are inside. So this is done with the command nm, so like name. And then you see that there is not that much symbol. You see that there is the symbol fwrite, but that is used in the library, and so it's basically the fprintf that we are using to set the warning, because here we have compiled with the wrong version, so with the warning message. So fprintf is actually fwrite to a specific file, which is called stdr, that is also u, so undefined. here, it's when you will compile it's at the linking stage that these guys will appear when the compiler will link with the C library. And we have one other guys here that is really related to compilation. Okay, and we see also these guys, so my square root, so which is our routine, so our implementation of the square root, which is here as a text, so in the text section of the library. So it means that it's executable code, so that's code that is executed. And here it is the address in the in this static library where this symbol is sitting. Okay, so let's have a try by adding a second routine to have a look at how this things is evolving. Okay, so that's just a second one, exactly the same, just with another name to see how things evolve. Okay, everything is successful, and let's call it nm again. So here we have a second routine, so my square root 2, okay, which is also in text code, but then a bit later in the static library. Last thing that we can do is to define, for example, integer that is a global variable. So for example, then it's square root a integer, and we can even initialize it if we want. Right, and then let's have a try to compile this. This is completely correct. And now we have SRT, weird, SRT, okay. It's QRT. And now we have an additional guy here, which is now not anymore a text. So in the executable section of, so it's not an instruction, it's a set of instruction, it's D, like data section. So now it's a value that's stored on the data. So you can look at the man page of nm to see you have a description of the meaning of each symbol, because there are others that are around. Now that's not, we don't want to be experts in nm, it's just having a look if you are compiling typically projects or libraries that are not, that you don't know, that are not developed by yourself, and you have a symbol missing somewhere, to check this nm command. So what we want to do now is to go further away, and then to now not link anymore to this compute.o objects, but with our library. Okay, so we will add here an library directory, for example. So a standard name, or very used, it's not you can put here the name you want. So I'm just using things that you will see in other projects typically. So libdir is, by convention, used for listing the different directories where the compiler should look for a library. So it's like minus include, so minus capital I, it's minus capital L, like library, and again without space, then and I've put it in the obj here, so obj directory. And then if I want to specify another directory, and then I have to repeat the manuscript capital L, and then another D here. Okay, but here that's not the case. The same for capital I. I didn't say it, so it's here minus I and something here. Okay, good. And now on top of our math library, I have to link with the square root library. Okay, and as you see, we don't, so it's minus, and then we are not saying lib square root dot a, so we forget the extension, and we are not putting the I and the B, so L like library and then the name. Okay, that's a bit misleading at the beginning, but this is linked to the possibility of having a library in two versions. One is static with .a extension. One is dynamic with .so extension that we will see in the next video. And the compiler decides which one you want to link against, and then you are just pathing. I want the lib square root. I don't care which one, dynamic or static. Okay. And yes, so we don't need that guy again, and we have to put the $lib dir before the libs, of course, and the libs is already there, it's already up to date. We have updated with a minus lib square root. Okay, let's try to compile this to see if it works. Yes, it works. So we have two separate compilations. We are creating two objects, so compute.o, square root.o. Here we are creating lib square root.a from this .o. So here there is a single .o, so it doesn't make that much sense. But in the case of a larger library, well, here you can have, I don't know, tens or hundreds of .o you want to pack into one single library. And then the linking stage is then, okay, I want from the build directory, so link these two guys, but in particular this guy that is you can found only in this build directory. And then we have our MySQRT, so build/MySQRT application. And let's have a look at something that we will see next time for dynamic library. So LGD is a command that can check for dynamic library dependencies of one application. So let's see what this guy says. So we are basically depending on something related to the kernel. This guy is a C library, so which is depending on the compiler, and this LD is for is something related to the linker, so the step where the compiler puts objects together. And so here you have no mention of lib, our square root library, because it has been really completely integrated into the application. Okay, so we have one executable and it is so-called self-contained. We don't have a dependency against another library like those ones. Okay, so that's an advantage. So we don't have to manage all dependencies existing on the system because we have now one on single binary. However, as soon as the application change or the library change, we have to recompile everything. Whereas when two are separated, like in the dynamic libraries, like we will see in the next video, you don't have to. We will see that. Right, we're done with static libraries. So we managed to create one static library. We were able to look at the different symbols they were present in the library with the nm command, and we managed to link an application against this static library. And yes, and that's it for it. So thanks for watching. Goodbye.